So, in this module we are going to look at some of the traditional ways to handle events. Event handling, of course, is something very old, almost as old as software itself. We have already seen one instance where event handling played an important role, that was simulation, and we are going to see now another, and that's user interfaces. The traditional way to deal with user interfaces to handle the events there is based on what we call the observer pattern. We're going to explain what it is, and we are going to explain what it's good for and also what some of its shortcomings are. That will lead us then in the next two modules to a different way to treat events in these programs, which is called functional reactive programming, and where events are essentially summarized in signals. The observer pattern is commonly used when we have some sort of model that maintains a state of an application, and we need to have one or more views that essentially present the properties of the model in some way. Variants of the observer pattern are also called publish subscribe or model view controller. The idea is always that we have some sort of model which captures the state of an application, and we might have one or more views that present that state, and there would actually be a varying number of views. So views can announce themselves to the model with an operation which we call subscribe. And the model will then, whenever there's a change, publish the fact that there is new information to the views. The view can then inquire the model about what the new state is and change its presentations. And because essentially views announce themselves as published, there can be more than one view. So there could be another one that also publishes, subscribes itself and gets the same published information. Sometimes in user interfaces we have a third component which is called a controller, which somehow manages the interactions between the model and the view, but the controller in fact is optional. So let's see how we could put this into code. Here is a trait for publishers, so it's expected that every publisher would inherit from that trait to gain the functionality of a publisher. What is that functionality? Well, publishers maintain internally a set of subscribers, which you see here. Initially that set is empty. So you can add a new subscriber by calling the subscribe method of a publisher, which simply announces a given subscriber. That's another trait which we will see next. And what it does is it adds the subscriber to the set with a plus equals. The dual of subscribe, of course, is unsubscribe, so a subscriber can also announce that it's no longer interested in published info of that publisher, and then the implementation of that would simply remove the subscriber from the set. And finally, a publisher has a publish methods. What that does is it goes through all subscriber and invokes for each subscriber a handler method that the subscriber must provide with the current publisher as argument. So let's see the subscriber next. Subscribers are very simple. All they need to have is this handler method, and we pass the publisher that published new information as a parameter to that handler. So let's go back to bank accounts, which you have seen before in the module about functional programming and state. You see the example of bank account that we have here again for a recall. So a bank account has deposit and withdraw methods, and it maintains a private variable balance. And of course the deposit method adds some amount to the balance, whereas the withdraw method subtracts it. So what do we need to do to make bank account a publisher? I have already given you the extension, so bank account now extends publisher. What we need to do, of course, is invoke publish, because otherwise nobody will ever know about changes in the bank account. Where do we do that? Well, every time we change the state of the bank account. So I would propose we put a publish here, and we put another publish here. One in with deposit, the other in withdraw. We're almost done. The one thing missing here is yet, well, once we have published, what is a view of the bank account, a subscriber, what's it supposed to do? Well, it probably wants to access important details about the bank account, and probably the most important one here is the balance. So right now there's no way to access the balance directly because balance is a private variable. So let's add an accessor method, call it current balance. Which simply provides the current state of the variable. Of course, we could have made balance simply a public variable, but that's not advisable because that would mean that everybody could not only read balance but also write to it. And I believe a lot of banks would get very nervous if you could manipulate the balance of your accounts or anybody's accounts like that. So here you see the complete picture of bank accounts. I have added all the things that I drew by hand to the code here. Current balance and the two publishers. So let's add a view to this picture. The thing I want to do is define a class consolidator that observes a list of bank accounts and that would always be up to date with the total balance of all the bank accounts. So the sum of all the balances in the observed bank accounts. Consolidator is a subscriber. So what this consolidator does initially is it subscribes itself to all observed bank accounts as an initialization action, observed for each subscribe this. What it needs to do then is maintain a variable, which is the total sum of the balances of all the bank accounts. I have written here private var total int equals underscore. That means that the variable is initially uninitialized. That's what the underscore does here. I initialize it by calling the compute method. So what does compute do? The compute method goes through all observed bank accounts, takes the current balance of each and takes the sum of these balances and stores the result in total. Compute is also called by the handler method of the subscriber. So whenever one of the bank account changes, compute is invoked again to recompute the total balance. Of course, one could envision more efficient ways to do this, maybe take the difference of the balance of this account and apply that to the total variable. But for now, we are doing the most straightforward and simple way, even if it's not the most efficient. Finally, there's an accessor method again, total balance, which gives you the current state of the total variable. So let's observe bank accounts with a little Scala worksheet. I've called it observers, and I've put it in the package week2.publish_subscribe, where I assume the bank account class is also located. So let's define a couple of bank accounts. We have a bank account A, bank account B, and now let's define a consolidator that takes the two bank accounts and always maintains their total balance. So we can find out what the total balance is by just calling c.total balance. And of course the total balance initially is 0. So let's do something with the accounts. Let's say we want to deposit 20 currency units in A. And we want to find out what's the total balance now. And that would give us 20. Well, no big surprise, but remember the total balance actually does not by itself always recompute. So indeed it only gives you the current variable total in the consolidator. So the consolidator has updated itself, as you can see there. Let's do another step. Let's deposit 30 units in B and do its total balance here. And we would get 50 as expected. So let's see how we would evaluate what we've done with the observer pattern. There's some good aspects. So one good thing is that we have views that are decoupled from the state. We can have a varying number of views of a given state, so that's good. And it was overall rather simple and intuitive to set up. But there are also some problematic parts to this design pattern. The first one is that you've seen that all the fundamental operations, publish, subscribe, handle, they return unit as a result, so they must be imperative. Everything they do has to be by imperative updates. The second problematic aspect is that, in fact, there are quite a few moving parts that need to be coordinated. So every subscriber has to announce itself to the publisher with subscribed, and the publisher has to essentially handle these things in a data structure. There are calls back and forth and so on. That also makes things more complicated when you add concurrency. One particular problem is if you have a single view that observes two different models that get updated both concurrently. In that case, the two models could call at the same time the handler method of the view, which gives us possible race conditions that have to be handled. A fourth disadvantage is that views are still tightly bound to the state that's represented in the models. Every view update is directly coupled to the state update. Once we update the state, the view gets updated immediately. Sometimes you want to have a looser asynchronous relationship between a view and a model. There was one interesting study by Adobe from 2008 where they looked at their code base, which is quite UI-centric, and they found that indeed event handling is a very important part. About 1/3 of their code in Adobe's desktop applications is devoted to event handling. And furthermore, that the code that uses event handling is also quite intricate. So more than that share, namely 1/2 of all the bugs in the code were related to event handling. So that shows that the traditional ways of doing events, while workable and standard, quite an industry standard right now, is far from being perfect. It's quite bulky and it causes a lot of bugs. So in the rest of this course, we'll explore different ways in which we can improve on the imperative view of reactive programming that's embodied in the observer pattern. In this week, we are going to look at functional reactive programming as an alternative to treat these event sequences in a functional way. In the next 2 weeks, then, we will look at related but different ways of abstracting over events and event streams with futures and observables. And in the last 3 weeks of this course, we will tackle concurrency head-on. We will express concurrency and handle it using actors.